So what we're doing now is taking our points that would be on our unit circle and our angles, and we're putting them on an XY axis. So the angles, or your theta values, become your x-axis, and your value of sine or cosine become your y-axis. And they create curves, okay, that are cyclic. This is one period of your sine curve. So from start to finish, one time around your unit circle would produce this curve, okay? If you actually, let me pull it in. If you were to like compare this and understanding where it comes from is based on the unit circle, angles, and in this case, it would be based on the sine function. So if I looked at my unit circle and I went, now notice these like key points are at 0, they're at pi, well, I'll go 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are your quadrant angles. So as I go around the unit circle one time, if I start at 0, what's the coordinate point at 0 on my unit circle? 1, 0. And if we're talking about sine, which of those is your sine? The x or the y? The y. So the y is 0 at 0, right? Which means your sine is 0 at 0, and that's where that point comes from. Then if I jump to the top and I'm looking at pi over 2, what's the coordinate point there? 0, 1. What's the sine? 1. That's why this coordinate point is pi over 2, 1. Then I go to the left and I'm looking at pi, the coordinate point there, negative 1, 0, right? What's the sine? 0, so it brings it back to the x-axis. Go to the bottom of your unit circle at 3 pi over 2. Your coordinate point is now 0, negative 1, which is why this coordinate point is negative 1. And then if I come all the way back around to where I started and finish at 2 pi, my coordinate point is 1, 0, and the sine is 0. So the initial curve of your sine function starts at your x-axis. We're going to do shifts on these. We're going to move them all around, but it starts at your x-axis. It goes up to 1. It comes back down to your x-axis, it goes to negative 1, and it comes back up to 0, okay? So this is the parent function of sine. We are going to stretch and shrink and shift these all around, okay? But this is what our initial function would look like. And one full period, which means one full curve, is done by going one full circle around your unit circle, which is 2 pi. This would be if I continued it. So because these are unending, right, I can keep going around my unit circle, or I could have gone negative around my unit circle. One curve looks like this, but it keeps going forever in both directions, okay? And so when it says graph one period, it literally means just one section of it. It would be 5 key points, one here, one here, one here, one here, one here, okay? And then if it said 2 cycles or 2 periods, I would just continue it. And you can continue it in both directions, but you would continue it on a little bit wider. All right, so let's talk about the first things we're going to get from our equation, and they are amplitude and period. The amplitude is half the distance between the maximum and the minimum values on your curve. So the amplitude is basically how high and how low this little wave goes, okay? It is found by finding the absolute value of a, and the a is the number on the front of your trig function. So if that said 2 sine, then my amplitude is 2. If it said negative 2 sine, my amplitude is also negative 2, because amplitude is always positive. It's the absolute value. The next thing you're going to find is the period. And this is how long it takes to complete one full cycle. And we find it by doing 2 pi over b. B is what's in between the trig function and the variable. It could be next to it being multiplied, but it also could be under it. So if that said sine of x over 2, for example, then my b is 1/2. And to find the period, I do 2 pi over that value. So 2 pi over b gives you the period. With me so far?
Yes.
Okay. Thank you, Elijah. All right, so here's our steps to graphing. We're going to start by identifying the amplitude, which is the absolute value of a. Then we're going to find the period, which is 2 pi over b. Then we're going to find 5 key points. So without a shift, which causes like a left to right shift, without something added or subtracted, our 5 key points are going to start at 0, and end at the period. So I start at 0 on the x-axis, I end at the period on the x-axis. And then my 3 middle points, I take the period and I multiply it times a fourth, times a half, and times 3/4. And you should end up with 5 key points. You're gonna plot those on your x-axis. You're gonna look for a phase shift. So this is what we'll get to tomorrow. A phase shift happens inside parentheses. We'd be adding or subtracting something from the x. If that happens, we're gonna add or subtract the phase shift, depending on its sign, from those key points, okay? And then we would plot the key points, and then we draw the curve. Because it's sine, we would start at 0, we would go up, down, down, up on our points. At the very end, we're gonna look for a vertical shift. So if we add something after the trig function or subtract something after the trig function, separate from what's inside the parentheses, this causes my graph to literally shift up or down. So we're gonna wait till the very end to do that. We'll also pay attention to reflection at that point, which we'll see in a second. All right, we're gonna start super basic. So y equals 2 sine x. So our first step is to identify the amplitude, right? What's our A? 2. A is 2, and the amplitude would be? Absolute value of that, which is 2. What's our B? B is what's in between the trig function and x. 1. And then the period is 2 pi over B, which would be 2 pi over 1, which is 2 pi. Then we're going to look if there's any shift. So if there was something inside here added or subtracted, which again, we're going to save for tomorrow, we would identify the phase shift. There's nothing there now. So I don't worry about shifting these points left to right. What I do is I take that period, I start at 0, and then I take that period and I multiply it times a fourth, times a half, just assume that always is going to happen, times 3/4, and then the last point is the period. So there should be 5 key points total, starting at 0, ending at the period, and then in between is the period times a fourth, times a half, and times 3/4. And then I simplify these. So 2 goes into 4 twice, and this is pi over 2. 2 cancels with 2, and this is pi. 2 goes into 4 twice, and this is 3 pi over 2. And then the first and the last stay as they were. When you're finished finding your key points, you should have 5. And those are going to go on the horizontal axis. So I'm going to draw myself a y-axis and an x-axis. The x-axis is your angles. So I start at 0. The next one is pi over 2. The next one is pi. The next one is 3 pi over 2. And the last one is 2 pi. And then on the y-axis, I'm going to label my amplitude. I'm going to go up 2 for the max, and I'm going to go down 2 for the minimum. And then based on which trig function would be how we plot the next points. This is sine, which starts at the x-axis on the first key point. It goes up to the maximum on the second key point. It comes back down to 0 on the third key point, goes to negative amplitude or the minimum on the fourth key point, and it comes back up to 0 at the end. And then I literally draw my curve. So that would be one period of the sine curve. If I wanted another, if it said graph 2, I could either reflect it over the y-axis, it would be the same points but negative, or I could continue it on and it would end at 4 pi because it would have duplicated the length. Good so far. How many of you remember this from last year? Okay, good. All right, you do this one. All right, so what's your A? 1/2. What's your amplitude? 1/2. What's your B? 2. What's your period? Good. 2 pi over 2 would give you pi. There's no phase shift. Again, we'll get to those tomorrow. So we start at 0, and then we would do pi times a fourth, pi times a half, pi times 3/4, and we finish with pi at the bottom, which will be all the way at the right. So this stays 0. This becomes pi over 4, pi over 2, 3 pi over 4, and pi. And then I go to my x and y axis. Now, if I had literally drawn for you 0 and 2 pi, let's say I had marked, you would have to make sure this is shrunk to be half its width, okay? But if it's an empty one, I don't care how wide you make them, as long as you know that if I had stacked those last two on top of each other, this one would be squished to be more narrow than the last one because it would have had to complete a whole curve on half the horizontal distance as the last one. So I'm going to mark 0, I'm going to mark pi over 4, I'm going to mark pi over 2, I'm going to mark 3 pi over 4, and I'm going to mark pi. 5 total key points. My amplitude is a half, so if this is 1, then I need to see a half. If this was -1, then I need to see -1/2. And then because it's sine, we're going to start at 0. We're going to go up to a half. We're going to come back down, go down to -1/2, and come back up to 0. Questions? Okay. This one just says determine the amplitude in the period and then graph the following. So on your quiz, no, on your test, sorry, that's what's next. You're going to see a little line for amplitude on these. So you'll literally get points for identifying the amplitude. You're going to get points for identifying the period. It's going to ask you for the key points, and then obviously it's going to ask you to graph it. So what's the amplitude here? 3. What's the period? 2 pi over pi, right? This time it's 2. You do not have to have pi in the period. There's no rule that says that, okay? Just like radians can have pi and don't have to. It's the same thing. So first key point is at 0. Then it'd be 2 times 1/4, 2 times 1/2, 2 times 3/4, and the last one would be 2. So this stays 0. This would be 1/2. This would be 1. 3 halves or 1.5, and the last one stays 2. 0, 1/2, 1, 3 halves, 2, amplitude this time, 3. So it starts at 0, goes up to 3, down, down, up. All right, what do you think would happen if I added a negative onto the front of this function? Does my amplitude change? No, because the amplitude is always absolute value. What does a negative on the front of a graph do? Flips it upside down. So instead of starting at 0 and going up to 3, I would start at 0 and go to -3. And my curve would look like this, okay? So a negative on the front flips the direction of your curve. It would be a reflection over the x-axis, but it flips it upside down. We good so far?
Yes.
Okay. So we're skipping over the phase shift on both sine and cosine, and we'll come back to it tomorrow. So when you get to your homework, anything that's got parentheses with an x minus or an x plus or a theta minus or a theta plus, you're going to skip those for tonight. Like I would get started on the homework for tonight, and then I would skip those and then save them for tomorrow. Okay, so what changes with cosine is the only thing that changes is its shape. Cosine starts at 1 because on my unit circle, now I'm going with the x values. So on the right, it'd be 0, 1. So I start at 1. I'm sorry, it'd be 1, 0 on the right, where 0 is. And then at half pi, my x is 0, so it brings it to the x-axis. At pi, my x is -1, so it brings it below the x-axis. On the bottom, it's back to being 0, and then I double back around to 2 pi, and it brings it back to 1. So cosine looks like a deep C if you turn it sideways, okay? It starts at the top, it goes down to the bottom, it comes back up again. But everything else is the same. How we find the period, how we find the amplitude, how we find our key points, all of that is exactly the same. So this one just says determine the amplitude and the period of y equals negative 2 cosine 4x. What would your amplitude be? Amplitude is 2. What's your period? Good. 2 pi over 4, which becomes pi over 2. I'm actually going to go through and graph this one as well. So my starting point is 0. My end point is pi over 2, which means if I had drawn this on a standard curve, this would be really squished left to right, like it would be a horizontal squish, because you have to complete it in a quarter of the width that you normally complete your full curve. So I'm going to get pi over 2 times a fourth, pi over 2 times a half, and pi over 2 times 3/4. This stays 0. Pi over 8. Pi over 4, 3 pi over 8, and this stays pi over 2. So I've got a key point at 0. This is going to be more narrow. I'm going to make it a little bit more narrow. Pi over 8, pi over 4, 3 pi over 8, and pi over 2. How wide you make it on an empty curve, it doesn't really matter as long as you understand if this was multiple choice, or if I gave you the grid, you would know it has to be skinny like that. And then my amplitude is 2. So I'm going to go up to 2, and I'm going to go down to negative 2. Now first I'm going to graph it as though it's positive 2, just so we get comfortable with it. Positive 2 cosine means it would start at the top, come to the middle, go to the bottom, come to the middle, go back to the top. And you want to round your edges. God bless you. You want to round your edges, so these should not be sharp curves. Okay? This should be not like a V. This should be a rounded U-ish. Okay? That would be if it's positive cosine. Because it's negative cosine, what would happen? It would flip. So instead of starting at positive 2, it would actually start at negative 2. It would come up to 0. It would come up to positive 2, back down to 0, and back down to negative 2. So the negative cosine would look like that. Still good? All right, we're going to skip the phase shift, and we're going to talk about vertical shifts. So a vertical shift is a number added or subtracted from the function outside parentheses. So even if there were parentheses here, if it said like sine of x plus pi, the plus 2 has to be after the parentheses, or it just has to be separate. It doesn't necessarily have to be after either, because they could put 2 plus sine on the front, and it would still be a vertical shift. So this sine plus 2 is going to be a shift up 2. And this cosine minus 3 is going to be a shift down 3. So I start the same way. Identify the amplitude, identify the period, find your key points, plot them, and then at the very end, I take all my points and I shift them up or down. So for example, if I was going to do sine of x plus 2, my key points would have been at 0, pi over 2, pi, 3 pi over 2, and 2 pi, and my amplitude would have been 1. And my non-shifted sine would start at 0, go up, down, down, up, and it would look like this. And then I would take all those key points and I would shift them up to units. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And my ending curve would be there. You don't have to draw both. Like if you understand what you're doing, you could shift it. But you could also draw both as long as you indicate which one should be your answer. So I actually give I'll let you use colored pencils or a highlighter on this test so that if you want to shift it, you highlight for me or you do your answer in a different color and then I know that's what you intended to do. And if I were graphing cosine, my same key points, 0, pi over 2, pi, 3 pi over 2, 2 pi. my amplitude would have been, is 1. Cosine would have started at 1, gone to 0, negative, 1, 0, back up to 1. And my initial curve would have looked like that. And then I would have taken and shifted down 3, 1, oops. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. And your shifted cosine curve would look like that. Questions so far? Okay. You do this one. So that says y equals negative 2 cosine 4x plus 1. All right, so what's the amplitude on this?
2.
Just positive 2. What's the period? Good. 2 pi over 4, which becomes pi over 2. What's the negative on the front going to do? Flips it upside down. A reflection over the x-axis. What's the plus 1 going to do? Shift it up 1. Okay, good. All right, do this. All right, this is what you should have gotten. So your A is 2, which means your amplitude is also 2. Your B is 3, period is 2 pi over 3. Key point starts at 0, ends at 2 pi over 3, and then I did the 1/4, 1/2, 3/4, and you got 0, pi over 6, pi over 3, pi over 2, 2 pi over 3. Plot those on the x-axis. You could draw your initial cosine curve, which starts at 2, goes to 0, negative 2, 0, and 2, and then you want to shift everything down 1. So it started at 1, it went to the midline, or the middle of it would have been negative 1, went all the way down to negative 3, back up to negative 1, and then back up to positive 1. Raise your hand if you got it right. Okay, good. Questions? Okay, so the last example, this we'll save for tomorrow, actually. The other thing that you're going to see in your homework is it's going to give you a graph, and it's going to ask you to find the equation. So if I had given you a graph, for example, just add something in here because it's going to happen in the homework. If I had given you a graph, let's say I give you a graph that looks like this. So what kind of curve is the parent curve? Cosine or sine?
Sine.
It's a sine curve, right? Okay. What do you know about your amplitude?
-2.
So the amplitude would be 2. This is flipped upside down, which means it would be a negative 2. And what's true about your period? It goes from 0 to 2 pi, right? Which means your period is 2 pi. And 2 pi, which means 2 pi over b equals 2 pi, which means b is 1. So this would just be negative 2 sine of x. So you're going to get, you'll see it on the homework, you'll get one where it gives you the picture and it asks you to identify the curve. You're looking for your amplitude stretch, you're looking for your period stretch, okay? If they give you, if your period is not 2 pi, then you can actually do 2 pi over the period to get the b. So I can do 2 pi over b to get the period, but I can also do 2 pi over the period to get the b. So it goes backwards. And then look for your things like a vertical shift or a reflection, that kind of stuff. So you can skip for now, for tonight, you can skip the word problems, and you can skip anything that's got an x plus or minus something in the parentheses. That will do the phase shift, and that will do tomorrow, okay?